Unit 3, Lesson 1, Congruence. Your objectives for this lesson are to specify a sequence of transformations that will carry a given figure onto another, to apply the definition of congruence to determine if two figures are congruent, and to apply the CP-CTC theorem. Okay, starting off, congruent. Two figures are congruent if they have the same shape and size. So this should sound familiar from what we've been looking at. So remember, same shape and size is an isometry. So in Unit 2, we were looking at different isometries. All figures that are an isometry of another are congruent. Two plane figures are congruent if and only if one can be obtained from the other by rigid motions. So if I could flip something, turn it, or reflect it. Oh, sorry, reflectives. Flip, turn, or slide it, then I have congruent figures. Okay, example 1. Use the definition of congruence in terms of rigid motions to determine whether the two figures are congruent, and explain your answer. Part A, I'm looking at these here. If I took this small figure and I tried to use rigid motions to get the big one, I could do that. So maybe this is a slide. I could slide down and over, but notice that those figures still do not overlap, okay? So that's because they're different sizes. Since there is nothing I can do here to get the small one on top of the big one without changing the shape or size, these are not congruent, okay? Not congruent. Different sizes. Part B, if I took this quadrilateral and I shift it over and then I shift it up, I see that these do overlap, and they overlap perfectly. So when I shift it or slide it to the right and up, the figures overlap completely. Which means that they are the same shape and size, okay? And that means that they are congruent. Another way to write congruent instead of writing out the word is with this symbol. It's an equal sign with a squiggle over it, and this does mean congruent. Example 2. For each pair of congruent figures, find a sequence of rigid motions that maps one figure to the other. So for these ones, I know that my two figures are definitely congruent. So that's given to you. And what I want to start out by doing is just look at these. And I notice that the triangles look like they're pointing in different directions. So I think the first thing I have to do is flip this or reflect it across the y-axis, and that would give me here. Okay, so first I'm going to reflect across the y-axis. But I'm still not overlapping. My two figures are still not overlapping. I need to slide it up. And how many units are we going to go up? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 units. When I do that, I have one figure overlaying the other. Part B. I'm going to try to map this triangle on top of this one, so right onto the left one. And looking at these triangles right away, it looks like I'm going to have to rotate this one to get on top of there. And I think I'm going to rotate it 90 degrees because this side, which was down here, is now pointing straight up. So I've gone from here to here. That's 90 degrees. So if I rotate 90 degrees, my rule for that is xy becomes negative yx. Okay, so after I've rotated, let me see what my new coordinates are going to be. This is at 4, 2, 8, 2, and 4, 10. So when I rotate, 4, 2 will become negative 2, 4. 8, 2 will become negative 2, 8. And 4, 10 will become negative 10, 4. Okay. So that puts me here. This is negative 10, 4. Everything else is lined up then. So this is after a 90-degree rotation counterclockwise. But you see, I'm still going to have to shift that up. So I'm going to slide it up. My x is going to stay the same, but I do need to move up 2 units, it looks like right here. So y plus 2. And now, there, perfect. Okay, properties of congruence. We have the reflexive property of congruence, which says that a segment is congruent to itself, or a point would be congruent to itself also. The symmetric property of congruence, which says that if segment AB is congruent to segment CD, then CD is also congruent to AB. So you can change the order. And the transitive property of congruence. So this says that if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then segment, oh gosh, this should be AB. Segment AB is congruent to segment EF. So since AB and EF are both congruent to CD, you can kind of take away the middleman and set AB and EF congruent to each other. The corresponding parts of congruent triangles are congruent theorem. Basically, this theorem is what it says. It says that if 2 triangles are congruent, then corresponding sides are congruent and corresponding angles are congruent. So the angles and sides are the parts, and since the triangles are congruent, their parts are congruent. Makes sense. You will see this abbreviated CPCTC because this is very long to write and very long to say, but it is a very common theorem. It comes up a lot. So when I say CPCTC, know that that is what we're talking about. Okay. Example 3. Triangle RGK is congruent to triangle MQB. So right here, write 6 congruent statements about corresponding parts. So we're going to start off by writing our congruent statements about the corresponding sides. So we could say segment RK, so that's this one side of the triangle, is congruent to segment MB. And notice that in your original congruent statement, R and M are in the same position, and R and M both come first in our segment names. So that's important. I don't want to see that RK is congruent to BM because it's not. R and M go together, so write them both first. Likewise, K and B are both congruent up there and down here, same spots. So from that, let's write the other statements. I've done this side. Let's use KG next. So segment KG is congruent to, well, K goes with B, we've already established that. G we haven't used yet. We haven't used Q either. So it is congruent to BQ. And our last side statement will be segment GR is congruent to segment QB. Oh, not QB, sorry, QM. And again, you want to use the letters that sit in the same positions in these triangles. So R and M, G and Q, K and B. Okay. Corresponding angles. So I'm going to use just one letter to name each angle here. I can do that because there's only one angle at each letter. I'm going to start off with R and M. You see I've already circled them in the same color. I know that those angles go together. So angle R is congruent to angle M. G and Q are also circled in the same color. They are in the same position for that triangle. Angle G is congruent to angle Q. Last, I have angle K, which is congruent to angle B. So again, same position, circled them in the same color. They are corresponding angles and they are congruent. That is all I have for lesson 1 of unit 3. So CPCTC and determining whether figures are congruent.